Hello friends, I welcome you all to this session on graph theory. So today we will be learning about degrees. So in that context we will be learning about that how to evaluate degree of any directed graph. So the first thing which you should understand about degree is that degree is always evaluated for a vertex. So whenever you are saying degree, so that means you are dealing with vertex. So in case of directed graphs, we normally evaluate three types of degree. First one is in degree, then out degree, and the third one is basically the sum of these two. That means if I represent in degree by d plus or deg plus and out degree by deg minus, then this is called as total degree, which is nothing but simply the degree, and that is the in degree plus the out degree. So the sum of in degree and out degree is what we call as the total degree of any graph. So to understand this fact, consider this graph, a directed one. So let's say this is the graph. Now in this particular graph, let me make this a directed one first. And the vertices are A, B, C and D. So now I am interested in knowing the degrees, in fact the in, out and total degree of each vertex. Okay, so in case of directed graph, let's start with any vertex A. So if this is the vertex, this is my vertex A, then how many vertices are coming into it? So first let me draw this one. So if you look, only one vertex is coming in and the remaining two are going out. So the in degree for this particular vertex, that is A, will be equal to 1. The out degree for this vertex will be equal to 2, as two edges are going out from this vertex. And the total degree of the vertex A will be the sum of these two, that is 1 plus 2, which is 3. Likewise, we can also go for vertex B. So if you look this closely, so one edge is going away, one edge is coming in, another edge is coming in, and one edge is going out. So this particular one is going out, this is going out, and this is coming in, this is coming in. So for the vertex B, we can see that two edges are going out and two edges are coming in. So the degree, that is the in degree for vertex B, will be 2. The out degree for the vertex B will be 2, and the total degree for this vertex will be 2 plus 2, that is 4. Now if you look this vertex C, so one edge is going out, one edge is coming in, and there is a loop. So it is going out as well as coming in. That's why it is a loop. What is a loop? I have told you in previous lectures that loop or self loop is that edge which starts and terminates at the same vertex. So how many they are going out, let's say. So this is going out, okay. and here the edge is also going out. Likewise, this is coming in and this is also coming in. So if you look this vertex C, then the in degree for this vertex will be 1 plus 1, that is 2, and the out degree for this vertex will be 1 plus 1, that is 2. So the total degree for the vertex C will be 2 plus 2, that is 4. Okay. Now comes this last one, that is vertex D. So here if you watch closely, that only one edge is coming into this vertex. So therefore the in degree for this vertex D is 1, as there is so no edge is going away, so the out degree for this vertex will be 0, and the total degree for the vertex D will be what? It will be 0 plus 1, that is 1. So in this way you can evaluate the in degree, out degree and total degree for this vertex, for the vertices of this graph. So once this is known to you, the better thing is, or the thing which you should do is, you should tabulate it so that it becomes easier for you also, or and also for the examiner who will be examining your copy. So let us try to understand this. So here what we'll be doing is, we will be writing the vertices, then in degree, then out degree, oh sorry, and then the total degree. Now we have 4 vertices A, B, C and D. Okay. Now for vertex A, what is the in degree? It is 1. What is the out degree? It is 2. Therefore the total degree will be 3. And that is what we have got there. Look, this 3. For vertex B, what is the in degree? 1, 2. What is the out degree? 1, 2. Total degree is 2 plus 2, 4. That is what we have done here. For vertex C, what is the in degree? 1 and 1, that is 2. What is the out degree? 1 and 1, that is 2. So the total will be 2 plus 2, 4. For vertex D, what is the total? What is the in degree? It is 1. What is the out degree? It is 0. And what is the total degree? It is 1. Okay. So uh, that is how we evaluate the degree in case of uh, directed graphs. Now let us take one more example to understand one more concept. So consider this graph. Now the vertices in this graph are A, B, C, D, A, B, C, D and E. And this is a directed, as we are having directions attached to the edges, or they are also called as arc, you know. So let us evaluate the degrees. So this is in degree, this is out degree and this is total degree, and then these are vertices, that is A, B, C, D, E. Now start with A. How many edges are coming in? So 2. How many edges are going out from vertex A? 0. What is the total degree of this vertex? 2. For B, this is out, this is in, this is out, and this is in. So 2 are coming in, 2 are going out. So this is 2 are coming in, 2 are going out, so it is 4. Okay. Now, if we look C, so for C, this is going out, this is going out. So nothing is coming in. So in degree for this vertex is 0 and out degree for this vertex is 2. So the total degree will be 2. If you look this vertex D, this is coming in and this is coming in. So both are coming in. So in degree is 2. Whereas nothing is going out. So out degree will be 0. So total will be 2. Look E. So if you look this vertex E, both the edges are going out. So the out degree is 2, but the in degree is 0. Therefore, the total degree is 2. So if you add the total in degree for each vertex, then you will be getting 2 plus 2 plus 2, 6. And likewise, if you add the out degree also, you will be again getting 6. So remember, in a directed graph, the in degree, sum of in degree should be equal to the sum of out degree. Second thing, the vertex for which the in degree is 0, the vertex for which the in degree is 0, as in this case it is C and E. So let me make it bigger. So first one is C, so this is C, and second one is E, this is E. So these vertices will be called as source. So vertices for which in degree is 0, they are called as source. Whereas if you look this one and this one, for these two vertices, that is A and D, out degree is 0. For A and for D, the out degree is 0. That means they will be called as sink. So nothing is going out. So they are collecting everything. They are absorbing everything. So therefore, the vertices for which the out degree is 0, they are called as sink. Okay. So in this lecture, what you have learned is that how to evaluate the degree of a vertex in case of directed graph. So basically, if you look this particular column, you will be able to understand what is a degree. So what is it? It is the number of edges connected to a particular vertex. But if it is directed one, as the problem we have done is a directed case, so for directed case, you also have to find out the vertices which are coming in and also the the edges which are coming in and the edges which are going out. That's why in degree out degree concept is there. So in this lecture, till this point only, thank you very much for watching it.